All right, so this question here, the number one thing that people are struggling with is the fact that they give you this little triangle on the inside, but if we read the description, does it ever say anything about that little triangle? It says nothing about it. So what's that little triangle there for? Nothing. Doesn't serve any purpose. So if I wipe that away, this is like question number 1 out of this assignment, where this is 37. Say that's 37, and that's my hypotenuse in a 30, 60, 90 triangle, right? A hypotenuse in a 30, 60, 90 triangle is always what relationship? What's the n, 2n, n equal 2, n equal 3, what is it? 2n. Okay, so then across from 30 is always what? N, so if this is 2n, what's n? Half it, so 37 over 2. Now I'm going to leave it that way because I looked at my answers down here and it asked me to simplify answers. It says type an integer or simplified fraction, so I can't type in 18.5, right? Okay, it's going to tell me I'm wrong because that's not a fraction. I can't multiply that out and get a decimal because it's going to type it in and it's going to be wrong. It's not a decimal, okay? So 37 over 2. Now if I want to find the longer leg, that would be this side, right? What do I do with n to find that longer leg? Okay, so I multiply by radical 3, so I get that. Okay? Now, some people have been typing that stuff in. Type in 37 over 2, 37 over 2 radical 3, and hit enter, and it's wrong because what is that unit right there? Feet. What is that unit right there? Inches. So if I'm in feet, so if I have 37 over 2 feet, how do I change that into inches? Times it by 12, okay? The idea is I've got 37 feet, okay, as my beginning unit. I want feet to cancel out and inches to show up. So inches have to be on top, feet have to be on the bottom. What's going to happen with that 12 and that 2? They're going to cancel, gives me 6, don't they? Okay, so then whatever 37 times 6 is, I'm going to say it's 222. So I get 222 inches. And then if that's the length of the inside in inches, isn't the other side 222 radical 3 inches? Okay. That's kind of how you approach that. So I think structurally with the picture, it confused people. You don't need that inner triangle. It's not useful. And then the second component of this is that they go from feet to inches. Those are little things, guys, that the end of course exam does. And that's why I like to give these questions, because it forces you to hopefully develop that attention to detail. Because if I'm taking that end of course exam and I'm zooming through that and I'm not paying attention to units, I might get 3 or 4 of those questions wrong. Okay? If I'm zooming through that and I'm looking at these pictures that are confusing looking and I'm not trying to eliminate or redraw the picture to eliminate the useless information, I'm probably going to mess up. Okay? So we have to pay attention to detail in order to be successful in that end of course exam. Same thing happens with how I write my answers, whether I write them as simplified radicals or if I write them as decimals or whatever. You know, if I'm on the end of course exam and it says write it as, I get 37 over 2 as my final answer, and I say write it as a fraction, and I type in 18.5, I am absolutely right, ain't I? I got the right number, don't I? I did all the algebra right, correct? I did all the geometry correct, right? But what are they going to tell me? I'm wrong, okay? And that kind of stinks, doesn't it? Okay? So we have to make sure that we pay attention to that, okay? Did we struggle with this one? Okay. Let's see here. All right, so I'm going to put these 3 pictures up here because I think as you're doing this type of problem, you're going to want to redraw pictures, okay? And I don't want to spend time in class redrawing them, so I'm just cut and paste them. But when I look at this problem, they ask me two questions. The first question is, how long is the longer brace? So the content of the problem is there's a storm, knocks this building down or something like that. They brace the wall up. Down here, they stake these two 2x4s or whatever they're using as braces into the ground. One makes a 45-90 triangle with the wall. The other makes a 30-60-90 triangle with the wall, but they're both staked in here at the same spot. Does that make sense? Okay. The first question asks you to find that length. Okay. That's what the first question asks you to do. Okay. So what a lot of people are trying to do with that is to look at that triangle. So would you guys agree that is the hypotenuse of the 30-60-90? So a lot of people initially are trying to do this. To look at that 30-60-90 and try to figure out what they're supposed to do. Well, if I look at that, do I know anything about that 30-60-90 triangle? No. Okay? So they don't know what to do. They get stuck. Okay? And I made the analogy last class. If I'm going to open a 1,000-piece puzzle, and I dump all the puzzle pieces on the floor, and I pick up two pieces, and they don't go together, do I give up and put the puzzle back in the box and leave? Yeah. Okay. No, usually you don't do that, right? What do 90% of people do that put a puzzle together? What do they start doing first?
Find the edge pieces.
Okay, that's usually what people do. They'll find the edge piece. So some people say, well, sort them out in like similar colors, but ultimately you try to make that border first before you start doing anything, right? Yeah. Because you know something about those border pieces, right? So it gives you somewhere, they got that straight edge, so it gives you some reference to start, right?
Yeah.
That's what we do here. We want to find a reference to start. Which triangle do you know something about in which you can start this problem in? The 45-45-90. So I'm going to start there. What?
Take them out. Nothing, you can keep on going.
All right, so I'm going to start there in the 45-45-90. Why would I do that? Now, doesn't it give me the hypotenuse to be 19? And in a 45-45-90, the hypotenuse is always what side? It's the longest, but in regards to n, it's n radical 2, right? Okay. Can I solve that? Okay, divide both sides by n, divide both sides by radical 2, I would get n equals 19 over root 2, correct? I'm going to rationalize that, and I get 19 root 2 over 2. That's the value of n. Isn't this side right here n? Is this side also n? Okay. Is that side the same? Yeah. Okay. So when I do that, isn't 19 radical 2 over 2 now a component of this 30-60-90 triangle? That's what side is that in a 30-60-90 triangle? Across from 30 is always n in a 30-60-90. What's the hypotenuse always going to be in a 30-60-90? 2n. Well, wouldn't that be just 19 radical 2? Does that make sense to everybody? Okay, so I just double my n value to get that. Doesn't this side become 19 radical 2 or 2 times what? Radical 3. Well, what's 19 radical 2 times radical 3? Good, 19 radical 6. Just multiply the radicals. So we have 19 radical 6 all over 2. That's that distance. The first question asks you, what is the length of the longest brace? Well, that's that blue value that I just circled, right? Okay. The second part of the question asks you, how much higher on the wall does the longer brace reach than the shorter brace? And what a lot of people throughout the day that have been getting this wrong have been doing is they've been finding the green distance fine, they find the purple distance fine, and they subtract those. Is that telling me how high those things reach on the wall? No. The distances I want to subtract are that distance from that distance, right? Okay? So this distance, the blue distance here, is 19 root 6 over 2. This distance here would be the purple one, right? Isn't that 19 root 2 over 2? So I'm going to subtract this. So 19 root 6 over 2 minus 19 root 2 over 2. Now we'll type that into my calculator. Now, depending on the calculator that you have, you might type that in thinking you typed it in right, but it gives you back wrong values because you typed it in wrong ultimately. Somebody in the last class was using TIA 384. They tried typing that in, and it started giving them a completely off-base value. Okay? And because on a TIA 384, we don't have the ability to see when I type the numbers in, those numbers being expressed how I wrote it by hand. If I use Desmos, which is the calculator that you're going to get at the end of the course exam, if I type in 19 square root of 6 divided by 2, do you see how that is different than what I wrote by hand? Okay, well, a lot of people type it in that way on the TIA 384, and it doesn't tell you that that's wrong. But that visually tells me that's not what I wrote by hand, right? So I know that's not what I want. I want that, right? Minus then 19 square root of 2 over 2. And now I get 9.8 as that answer. Does that make sense to everyone? Okay. The syntax, okay, that's what we talk about like as the grammar of typing that stuff into our calculator is different per calculator because of the way they're programmed, okay? Some calculators might need extra parentheses than what other calculators do, okay? The TIA 384, if you can learn that one, it's really nice because of how, you know, TI is predominantly the calculator that's used across all of education. Desmos is kind of entering that market and starting to take away from that from TIA 384. But there's a lot of syntax in that calculator and understanding that calculator that it's going to mess you up if you don't understand how it works. I told the last class, you've seen people that get like a leg injury in a sport, and the trainer gives them one crutch. But if they just give them one crutch and never show them how to use it, you've probably seen a lot of people like walking at, we laugh as coaches sometimes or teachers, sometimes we see students walking around, they've hurt their left leg, they put the crutch on their left leg, and they start walking on their left leg with the crutch. Is that really doing anything? No, they hurt the left leg, they need to keep that off the ground, right? But they've never been shown how to use that crutch, so they don't know how to use it, it's not going to help them to their advantage. Does that make sense? If you don't know how to use the calculator, is it going to help you to your advantage? That's what last class. If I got, you know, those they got fancy like wheelchairs now, right? They got like motor operated, all that kind of. They got joysticks and buttons and all that kind of stuff. If nobody shows me how to use that, am I going to get where I need to go efficiently? No. Okay. I can turn it on. I can move the joystick in circles and all that kind of stuff. Push the buttons. I can do that because anybody can do that. Okay. My 3-year-old, 4-year-old can do that. Okay. You can do that with the calculator. I can give my 4-year-old a calculator. She can hit the plus button and the 9 and the 2 and the right and do all that stuff, right? And it spits stuff back. But she doesn't know how it works. So is that stuff spitting back the information that's corresponding to the problem that she wanted? Does that make sense to everybody? If I don't know how it works, it's not working to my advantage. So as you guys are using calculators, take the time to learn how they work, okay? I wish we had a class. I wish we had like a semester class that says this is how you use a TIA 384. Because that would be beneficial, okay? But those are little things that you're going to have to learn on your own. I've been telling, think about, when I graduated college, guys, I graduated college in 2007, okay? TIA 384 was the best calculator you could have. It did everything, okay? Now we got Desmos, we got GeoGebra, we got all those things. And I didn't have any classes to take. I had to learn those things on my own and see how they work and manipulate them so I can use them effectively, right? As you guys are getting older in today's society, what you learn in college, you go through 4 years of college, 6 years of college, whatever, the instant that you get into a job, you're probably going to have to change and relearn things that are different than what you were taught when you were in college because we just view them differently after 4 years or 6 years. Does that make sense? Okay? But you have to be able to adjust. You have to be able to learn new systems and be able to teach yourself those systems because ultimately technology is going to be a big part of your careers at no matter what you do, okay? That makes sense? My wife is a speech pathologist. She works with people and teaches them how to swallow, and stroke victims how to swallow, little kids how to talk and speak right and all that kind of stuff, right? She has to use a computer on a regular basis and different databases and understand how they work and how to bill patients and stuff like that. And her job gets transferred from company to company all the time, and they use different databases all the time. She has to learn new things on the fly. Does that make sense? If she refuses to do that, she gets fired, right? No pay, okay? And we have to live in a tent out on the golf course, right? So you have to be able to adapt and take it upon yourself to learn those little devices, those things that are going to help you. Okay, so those two numbers, gymnastic, like condense them into one value, one expression. Is that what you're saying? Okay, so here's the question, guys. With multiplication with division, so if I had something like 2 root 3 times 3 root 2. Yesterday we said we can rewrite that as 2 times 3, which is 6. And then under the radical, 3 times 2 is 6 again. We can rewrite that as one condensed value, right? We can actually do the multiplication that is being implied there, okay? With 19 root 6 over 2 and 19 root 2 over 2, the only thing that we can do here, because they have the same common denominator, is to write it as 19 root 6 minus 19 root 2 all over 2. That's the only thing we can do. And I'll try to explain this to you using smaller values than 19. So let's say that I had something like, let's just say 3 root 2 minus 5. Let's do addition first, because addition and subtraction are the same. So it's easier to explain with addition. Let's go 4 root 2. Okay? What the 3 root 2 is, it's 3 times root 2, right? It's 3 times some number that's being expressed by that symbol, radical 2. What that means is repetitive addition. It means radical 2 plus radical 2 plus radical 2, doesn't it? If I have 3 times 8, that's what that means. It means 3 plus 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 3, right? Or 8 plus 8 plus 8, okay? Either way you want to think about it. Here, I don't want to think about it as the fact that I have radical 2 3s, because that's hard to think about. I don't have irrational parts of a 3. It's easier to think I've got 3 radical 2s, okay? So I'm going to rewrite that as the implied addition, radical 3 plus radical 3 plus radical 3. Sorry, they're 2s. Let me mess that up. So radical 2 plus radical 2 plus radical 2. I got 3 of them, right? The 4 radical 2 tells me I have how many? 4 of them. So plus radical 2 plus radical 2 plus radical 2 plus radical 2. And now, are all of those like radicals? How many of those, if I went through counting how many radical 2s I have, how many do I have? 7. How do I get to that quicker than writing those all out? 3 plus 4. I add the numbers out front, correct? Okay? Now think about why that's the case. If I have 3 radical 2 plus 4 radical 2, what do they both have in common? Radical 2. Factor that radical 2 out. You get 3 plus 4, don't you? What's 3 plus 4? 7. Radical 2 now times 7. Well, we usually put that 7 out front, right? So because of that factoring process, we can verify that makes sense, that we just add the numbers out front. You might have had a class last year, a teacher last year that said, when I have radicals, we can kind of treat them like a variable. They really are. Any number we treat like a variable, because a variable is just a symbol that expresses a number that can change, right? So if I write 3x plus 4x, well, what if I say x is radical 2? Is that expression the same thing I have written up there in green? What would you call that? What's 3x plus 4x? You'd call it 7x, right? Okay? Now here's where I'm going to explain why we can't combine these here. If I had 3x plus 4y, would you call that 7xy? No, you can't combine those, right? They're not like terms, correct? They don't have anything in common that can be factored out like we saw down here, okay? So let's say x was radical 6 And let's say y was radical 2, and I asked you, can you simplify those? You can't, because they're not like radicals. Does that make sense? In order to determine whether I can add or subtract radicals, the number underneath has to be the same, and if it is, then I can add, subtract, whatever those numbers out front are. Okay? I'm trying to blank what I was thinking. This is it. I have 3 radical 8 plus 2 radical 2. Can I add those guys?
Maybe.
Maybe. What's the maybe?
8 can be divided by 2.
Okay. So when the radicand is not simplified, there's a perfect square inside this radical 8, right? So I'm going to rewrite that radical 8 as 2 times root 2. Does that make sense? Radical 8 goes down to radical 4 and radical 2, right? So that's 2 root 2. Plus then this 2 root 2, that's that there. Alrighty. Got 2 root 2 there. What's 3 times 2 root 2? 6 root 2. Plus then 2 root 2, right? So what do I get here? 8 root 2. If I'm uncertain about whether these approaches are working, if I'm doing the right thing, can I say 3 square root of 8? Add to it 2 square root of 2. I know that that's the value I'm looking for. Because there I haven't done any algebra, right? That was just what the problem I started with. If I think that what I've done is, and I'm uncertain about whether it's 8 radical 2, type in 8 radical 2, does it give me the same result back? So that can verify that, yeah, you've done the steps correctly. So whatever algebra you did was right, learn that algebra. Teach yourself that algebra, and use that over and over again throughout the rest of your career with algebra. Does that make sense? Okay. That's a really good question, Jimmy, because we're going, at some stage, we're going to deal with questions where I ask you to leave the answer as 19 radical 6 minus 19 radical 2 over 2. All right? I'm looking for those things because I think it's appropriate and it's important for us to understand exact values and when it's necessary to have them and when it's okay to round them. Okay, here I want to leave this one as an exact answer. Is that all right? Okay. Let's do, I want to talk, there was a question about chopsticks. Did I mention that? Did you guys be okay with that one? Have I ever used chopsticks? Yeah. Okay, so it said you had a square plate, right? And it wanted to know the dimensions of that square plate if you were to take like a, I don't know, 24 centimeter chopstick and laid it laid it across the diagonal. Okay, yep. And it wanted to know what the dimensions of the plate were. We don't know the length and the width. Well, it's a square, so what's the length and the width going to be related to one another? The same. What kind of angle is that? 90. If this is a square, right? A square is also a what? Okay. It's a rectangle. All right. So along those lines, a square is a rectangle and it's it's a parallelogram, but it's a rhombus. Okay. And the reason I want to talk about it being a rhombus is because there is a property about rhombi that is important to us in regards to that angle. What does that red diagonal do to that angle in a rhombus? It bisects it. Okay? So, that angle right there, that with the red and the blue side, isn't this angle right here 45 degrees? Okay, so 45, 90, this is 24. Is that my n root 2 side? Okay, so now I'm going to say I want to solve for n. So n root 2 equals 24. N equals 24 over root 2. How do I rationalize that? Okay, so root 2 over root 2 gives me 24 root 2 over 2. 12 root 2. And that's n. So that is that length right there, correct? All right. Now, here's the thing. I want you to take this a little bit further. I want you to find the area of that plate. How do I find the area of a square? Okay, S squared. So 12 radical 2 is S, right? Square that. What's 12 squared? 144. What is radical 2 squared? 2. What do I get? 288. What are these units? Are they centimeters? So it would be centimeters squared. Now, here's the thing. Why is that important? That's a pretty nice number, isn't it? Okay? If I were to take and deal with values that were not exact, so let's say that I got that 12 radical 2 number, 16.9. Let's just say I leave it at 16.9. Okay? Is that what that number was? Okay. And now I want to double that. So not double, square it. 16.9 times 16.9. Do I get 288? No. Okay. So do you see the impact of rounding there? Okay. Where if I can round at the last part or the last point, that's great. Or if I can keep it as radical and do further algebra with it, that radical might dissolve itself because I might square things. Does that make sense? Okay. And just the need for rounding disappears. Okay. So that's the purpose, guys, of why I'm going to ask you, leave your answer as 12 radical 2. Because the next thing that we do with it might dissolve that radical 2 and make it really nice for us. Is that all right? Okay. What about, there was a question that looked like, I think I still got this one. Anybody have issues with that? If I look at the triangle on the right, can I do anything on that triangle on the right? What? What do you know about that triangle on the right? Okay, it's 30, 60, 90. And if it's a 30, 60, 90, understand the goal at hand with 30, 60, 90 triangles and special right triangles is that they are to give you one value and you find the other two side lengths, right? Do they give that to me in the blue triangle? No. Okay? So it's the idea of if I pick up two puzzle pieces and put them together and they don't fit, or try to put them together and they don't fit, what do I do next? I put one of those puzzle pieces down and I pick up another one, right? And I keep trying to fit new ones together. So let's look over here. Is there anything over here in this triangle on the left that might be of service to us? Yeah, that 3 radical 2 is what side for a 45, 45, 90? It's the hypotenuse. So what is n in this case? It'd be 3. And n is going to be the side opposite the 45, right? So is that 3? Is that 3? And now what do you know about the figure on the right? You know one side now, right? You've transitioned into that right triangle. You know that, okay, in a 30, 60, 90, across from 30 is always what letter? N. The hypotenuse is 2n, so what's that number going to be? 6. The side opposite 60 is always n radical 3. The next question I'm going to ask eventually is what's that distance? How do I add them? What do I write? Okay, so 3 plus 3 radical 3, does that equal 6 radical 3? If I wrote out how many radical 3's I have right here, would I have 6 of them? No. That's all I can do, okay? We don't do the summation. We don't come up with a final sum for those things. We write it as the implied addition. What I mean by implied is I'm telling you you're supposed to add those, right? Yeah. But because I don't come up with one concrete sum in which the plus sign disappears, I'm telling you that you can't combine those. They're not like terms. You just leave it as 3 plus 3 root 3. Okay? If I want to go to Lowe's and tell Lowe's, hey, I need 3 plus 3 root 3 feet of lumber, they're going to say, go to Menards. Okay? Because I can't do that, or I don't do that. I would go to Lowe's with that. I would type that in my calculator, go to Lowe's with a decimal. Does that make sense? Okay? But there are applications where 3 plus 3 root 3 is going to be preferred over whatever that is as a decimal. Okay? Is that all right with everybody? There's a lot of algebra, guys, that we need to understand, we need to work with, and radicals are kind of one of those things that people struggle with because They're obscure. They're weird. They're symbols for other numbers. Does that make sense? And because of that, I think we're hesitant to just kind of dive in and start working with them. But they're going to be critical for the rest of your high school career. Okay? I'll show you kind of what my other classes right now are working on. And it doesn't matter what route you take in high school, whether you take the college algebra, trigonometry route, or you take the integrated routes, you're going to need to know how to do some of this stuff. And I'm going to just kind of show you the radicals that my class has been dealing with. I can get this thing to load. So this is, Kenny asked the other day, he's like, do other triangles have like these templates? Yes, they do. The short answer to that is yes, they do. But we'll never have like a 40, 50, 90 triangle that we have to memorize a template for. Okay? We have information like sine, cosine, and tangent. Those are kind of the templates that are going to allow us to find information about other triangles. This involves that kind of stuff. Look at those numbers up there. Do you see a lot of radicals up there? And you see a lot of fractions up there? Okay? By forcing yourself to avoid them, when you get to this course or other courses that involve the same stuff, just go at a slower pace, that's going to blow your mind. Okay? Take it from somebody that's been in your seat. I've done that. Okay? I didn't take Algebra 1 as seriously as I should have. And then when I got to college algebra, I had to do double work. I had to go figure out, okay, what are we talking about here with some of this stuff that I should have learned last year or the previous year. Okay? If you can learn it real well now, it's going to make next year and the year after that cakewalk for you. Okay? Because those courses are just piecing things together. It's not learning any new procedures or anything like that, or new ideas with math and things that we can do with numbers. It's just piecing 2 or 3 ideas together to get a new idea. Does that make sense? Okay, so if we can learn those foundational concepts, it's going to pay off greatly for you. Okay. I don't have anything else for you guys unless you want to talk about some more examples. Remember that 8.2, that first one is due tonight. Okay, because we were at school when that one was assigned, so I gave you a little bit of extra time than I normally would on that anyway. So that's the reason that one's due tonight. The other one was a blizzard bag day. Hopefully you get that done in the near future, but it's going to be open till I think March 6th is. I got to change it to my thing right now. I got March 1st, but I got to change it to March 6th because that's the deadline by law. Get those done soon, though. I can do anything with you.
All right, let's do 60. I gotta get ready for Can I go ask you?
Huh?